Alright, today's lesson was on exponential growth and decay. This is the function, right? The capital letter A is not important. T is the important. This is functional notation. The function name here is A. The little a is the initial value. And R is the rate of growth or decay. And T is a unit of time, usually years. Okay, so what we're looking at is the formula for exponential growth or exponential decay. And A is how much you're starting with, so you got to have something to grow, so that's where you're starting with. And it's always going to be some relation to 1. So if it's 1 plus a growth, 1 plus a rate, it's going to be growing. If it's 1 minus a rate, it's going to be decaying. Right? So if it's bigger than 1, it's growing. If it's less than 1, it's decaying. And when I'm talking about bigger than 1 or lesser than 1, I'm talking about the base of this exponent t. If the number here being raised to the power is less than 1, it is decay. If the base of the exponent is greater than 1, then it's growth. So here, if you think of this as just 1.06, right? That's what 1 plus 0.06 is. This is a growth problem, right? This formula represents exponential growth. What is the initial value? The initial value is here, so it's just 5. What is the rate of growth or decay? The rate of growth is this part. It's the 6%. It's how far this value is, the 1.06, from 1. Well, you could just subtract 1 from it. If you get a negative answer, just drop the negative. You want absolute value of the difference between the base of the exponent and 1. So here it's 0.06. Right? Here, h, is this growth or decay? So the base of this exponent is 1.12. This number is bigger than 1, so it is growth. And what's the initial value? The initial value is the coefficient over here, so it's 1200. Also something to consider. Remember, initial value is what happens when it's times t equals 0, right? At the very beginning. So you can just plug in 0 into the expression. If you plug 0 into this expression, it would be 1.12 to the 0 power. 1.12 to the 0 power is 1. So it would be 1200 times 1, which is 1200. So that's another way to get initial value. Just plug 0 into the problem, into the formula. And what is the rate of growth? The growth, remember, it's how far this is from 1. So you just subtract 1 from this, and I get 0.12. Alright, continuing. So here, in P of x, the base of this exponent is less than 1. So this problem is decay. And the initial value is the coefficient here, so it's 18. And how do I get the rate? You subtract from 1. If you do 1 minus 0.72, you get 0.28. If you subtract in the other order and you get a negative answer, just drop the negative and just rate. So this is a 20.28 rate of decay. Here, so the base of the exponent is 1/4. It's smaller than 1, so this one is decay. Alright, what is the initial value? Well, it's the coefficient out here, so it's 2. Right? And what is the rate of growth? The rate of growth is not 1/4. It's how far is 1/4 from 1? It's 3/4 away, or just 0.75. Continuing. Alright, looking at the base. The base is 4. This is definitely bigger than 1, so it is growth. Alright, what is the initial value? Well, there is no coefficient, or you can think of the coefficient as 1, so the initial value is 1. Right? Or you can plug in t equals 0. 4 to the 0 power is 1. So this has an initial value of 1. What is the rate of growth? How far is this 4 from 1? It's 3 units from 1. So it's just 3. So you got a rate of growth of 3. That means it is tripling every so often. Alright. Write an equation to represent each function. A new car costs $29,000 and it's depreciated at 15% each year. Write a function to represent the car's value after t years. So I'm going to use the letter C for the name of my function because I'm talking about a car. And we're using t for the time. What is the initial value? Remember, this is our formula. We have an initial value. So the initial value is 29,000. And it is 1 plus or minus the rate, right? Depreciation means it is going down. So it's going to be a minus. So it's 1 minus. And the rate is 15%, but you got to write that as a decimal, which is 0.15. And then you have an exponent of t. And you are welcome to simplify that. That will be 0.85 to the t. Okay, and let's go ahead and do C before we go on. What is the value of the car after 10 years? So we're going to use this formula, and we're going to plug 10 in. So C sub 10 equals 29,000. And plug 10 into this, so it's 0.85 to the 10th power. I do not expect you to do this by hand. Go ahead and put it into the calculator. So we're going to go 29,000, 1, 2, 3, times 0.85 raised to the 10th power. And I get this. Now remember, this is money, so I'm going to round to the nearest penny. So that'll be 0.36. So 5709. Oops, I wrote it wrong. 5709.36. Let's double check that. I thought I had a different answer today, but I guess not. All right. There we go. That's it. That's A and C. Looking at examples B and D. Holte Freeze had 20 stores in 2018, and the owner plans to open an additional 8% annually. I guess I should have zoomed in for the first one too. Sorry about that. Okay, Holte Freeze. So let's call this function h of t for Holte, and the initial value is 20. And we're growing, we're opening additional stores, it's 8%. Remember to change the decimal, just change it to a decimal, so it's 1.08, and our exponent of t. So there is our formula. Of course, you don't have to leave it 1 plus 0.08, you can write 1.08. Alright, how many stores will Holte Freeze have by the year 2025? Well, this formula starts at year 2018. And we're talking about what happens we have by 2025. So we subtract the two. So 2025 minus 2018 is 7. So we're going to plug 7 into the formula. So h sub 7 equals 20 times 1.08 to the 7th power. Let's do that. So that's going to be 20 times 1.08 to the 7th power. To the 7th power. If you don't know which button is your exponent button, ooh, there's something cookie on there. There it is. It looks like this little, this is called a caret, okay? And press enter, and I have 34.27. Now we're talking about the number of stores, so we're going to round it to the nearest whole number. And that's it, 34 stores. This is 34 stores. And this was $5,709. Alright, that's it. Hope that makes more sense. If not, you can ask me to explain some of the time again in the classroom. If I could get this to turn off.